Hey Year 12, we're back. Index laws today, and again this is not work that you haven't seen before. This should be revision. So, first of all, we are multiplying some terms together. We can't always add and subtract terms, not unless they're like terms, that's what we were looking at earlier on, but when we're multiplying we can always combine them together. A couple of things before we go too much further is I want to talk about some language here so it helps my explanations. Right, we have a base, right, base, exponent, and we want to talk about a coefficient as well, which is going to be this number out the front. So if we don't appear to have a coefficient, it's going to be a 1, we're familiar with that. If the coefficient appears to be negative, it's negative 1. Right, we have our base here, the exponent, sometimes called the power. Okay, I want to use that language, it makes it a bit clearer to talk about these things. So first of all, we are multiplying two terms together that have the same base. So y cubed by y squared, base stays the same, is y, and that's going to be to the power of 5. We add those things together because this y cubed means y times y times y. Y squared, y times y. So when we multiply those two terms together, there's a string of 5 y's all being multiplied together. Right, gives us, and we write that as y to the power of 5. Over here we have multiple bases. So just work through them one at a time. A by a squared is a to the power of 3. B to the power of 3 times b, b to the power of 4. Okay, just like that. Now, the reverse of this, the second of our index laws, if we will, we are dividing terms. Now, typically when we are dividing things in algebra, we write them as a fraction. In this case, I don't think it's going to be necessary. You could, but you're probably going to end up converting it back afterwards anyway. So, y cubed divided by y squared, we subtract the exponents this time, and I just get y. Now, it could be y to the power of 1, but we don't say to the power of 1. We just leave it like that, right? Why? Because I said so. Next up, a to the power of 5, b cubed divided by a squared b. We subtract 2 from the 5, gives me a to the power of 3. b cubed divided by b, b squared. Right, there we go. Easy. Done. Power of a power. Okay, I've got brackets now. I've got a power outside of that. I've got an exponent outside of the brackets. This time we're not adding them together, we multiply them together because in this example here, y cubed all squared means y cubed times y cubed, right? That would be like 3 plus 3, right, is 6. So I multiply those together, I get y to the power of 6. Now over here, I have a coefficient inside the brackets. So that means I have 2 to the power of 4. I have x cubed to the power of 4. Right, 2 to the power of 4. 2, 4, 8, 16. So that's, my coefficient is 16. That's still 2 to the power of 4. But x cubed to the power of 4, I multiply those parts. Right, 3 4 is 12. So 16x to the power of 12. Nice. Again, multiple bases, that's just fine here. A to the 5 all squared is a to the power of 10. B cubed all squared is b to the 6. Nice. Now, something raised to the power of 0 essentially means divided by itself. And what happens if I divide a number by itself? I get an answer of 1. So if I raise something to the power of 0, it means I divide it by itself. I get 1. 4y to the power of 0, 1. Now, 4y to the power of 0. How is this different? Well, that exponent only belongs to the y, not to the 4. It belongs to the base, not the coefficient. Here, my base is 4y. Here, my base is y. So, this term here is worth 1, but that means 4 times 1 equals 4. Right, good example there, how those two things are different. Right, something raised to the power of 0 equals 1, but not everything here has been raised to the power of 0. So far, multiplying, dividing, raising to a power, and a power of 0. Just a couple more examples here before this somewhat longer video finishes, right? Just a little bit of practice. So 6m to the 7, 7m to the 6 is 42m. Oops, I missed one. Back. 42, not 4. 42m to the 13. Right, multiply the coefficients, add the exponents. Over here I'm dividing. 48 over 6 equals 8. Right, 8. P squared over P is just P. Q to the 4 over Q3, Q to the power of 3 is just Q. 8PQ, mind your P's and Q's. There's not going 2 for today. Next up, I think this is the last one. Is the last one? This is the last one. See how organised I am. 5x to the power of 4, all cubed. I need to do 5 cubed is 5 times 5, 25 times 5 is 125. Then x to the power of 4 to the power of 3 is x, not to the power of 7, x to the power of 12. There we go. All done. That's our video for today. I'll see you in class.